Good morning, all. Today I will discuss regarding the second experiment, realization of logic gates using universal um, logic gates. Okay. In the first experiment, already discussed realization of logic gates using discrete component. Second one, we will discuss realization of logic gates using universal logic gates. So first, let us see what is meant by universal logic gates. So this is our second experiment, realization of logic gates using universal logic gate. So what is meant by a universal gate? So universal gate is a gate which can implement any Boolean function without need to use any other gate type. So what are the best examples of the universal logic gates? NAND gate and NOR gate. So what is meant by an universal gate general? So generally, universal gate means you are saying the examples of universal gate are NAND gate and NOR gate. NAND gate and NOR gate are called as universal gate. Why? Because we are having so many basic gates like AND gate, OR gate, NOT gate, okay, or XOR gate or XNOR gate. All these gates, okay, without using that all these gates we can realize or we can implement by using NAND gate and NOR gate. Means any Boolean function, means it may be AND operation or OR operation or inverter operation, all these operations we can inculcate by using NAND and NOR. Means the operation of the OR gate or the operation of the AND gate or the operation of the NOT gate or the operation of the XOR gate or the operation of the XNOR gate. All that gates we can realize by using NAND gate or NOR gate. Okay. So let us see. So aim to construct logic gate, NOT gate, AND gate, OR gate, XOR gate, XNOR gate, basic gates using NAND gate. And the same thing we can implement with the NOR gate also. So NAND and NOR are called as universal gates. Okay. So we will see how we can implement any one of the other basic gates by using NAND or NOR. Okay. So let us take the NOT gate. Okay. So NOT gate means nothing but NOT gate we have discussed in the first experiment. It is nothing but inverter operation. So if you provide NOT gate means if you provide 0 as the input, the output will be 1, or if you provide 1 as the input, the output will be 0. Okay. So this is the symbol of NAND gate. This is a 2 input NAND gate. So here I am using a NAND gate, but I want to perform NOT operation. Means whatever the input I provide, at A, at the output Y, I want to get opposite or complement or inverter of A. So for example, if I provide 0 at A, my output at Y should be 1. Similarly, if I provide 1 at one logic 1 at input A or 5 volts at input A, my output should be logic 0. Okay. So how to perform this NOT operation? By using here the symbol, whatever the symbol you are seeing, it is 2 input NAND gate. So the operation of NOT gate we want to accomplish by using NAND gate. So what is the connection? Simply the 2 inputs of the NAND gate we want to combine and provide the same. Okay. So if let us see 0 0. For let us take A, first case A is equal to 0 volts. So 0 volts means both inputs are providing 0 0. So 0 0 means what is the you have already we already know the 2 input NAND gate. 0 0 means what is the outputs of the NAND gate? NAND gate means nothing but complement of the AND gate. 0 0 for the output of the NAND gates are for 0 0 the output is 1, for 0 1 the output is 1, for 1 0 the output is 1, but 1 1 the output is 0. Okay, when both the inputs are high, then the output is 0 in the case of NAND gate. Okay, so let us take this is this, so 1 1. So yeah, for example, if I provide 0 0 0 0 means what is the output? 1. Similarly, if I provide 1 1 1, for 1 1 what is the output of an AND gate? It is 0. Okay. So let us see how we will connect on the trainer. So this is the trainer what we have already seen in our laboratory. So these are the inputs. So these logic inputs means either 0 or 1. So here one button will be there. If you move this button to downwards, it indicates it is logic 0. If you move that button topwards, it indicates logic 1. At the same time, if you move this button to top side, here this LED will also glow. That indicates that you are providing logic 1 or 5 volts. Okay. If you move this button to bottom side, okay, this LED will off. That indicates that you are providing 0 volts or logic 0. So these are these buttons are used for providing input, and similarly these buttons are used for uh, showing outputs, logic output indicator. So if you observe in this diagram, so an NOT gate implementing by NAND gate. Okay, so how many NAND gates are there? Only one NAND gate is required. So if you observe here in this trainer kit, this is AND gate, this is OR gate, this is NAND gate, this is NOR gate. Since we are realizing all the gates using NAND gate, here how many NAND gates are there? 4 NAND gates. Among these 4 NAND gates, how many NAND gates are required? Only one NAND gate. Okay, so this is two inputs, this is output. Okay, so output should be connected to logic output indicator, and for this two inputs, from here you want to provide the connection. So here if you observe in this diagram, both the two inputs of the NAND gate are given to same input, means so this one you want to connect here. For example, if this is A, okay, this I3 is A, so this one should be connected here. The same another wire you want to take and you have to connect here. Okay, now you want to take one wire here and connect this output to logic out input indicator. Okay, so depending upon the inputs you are providing, you will get the outputs here. Okay, so this is things regarding, means simply you are implementing the NAND NOT gate operation using simply a single NAND gate. Okay, next, similarly, how this is the output of this is the truth table of AND gate. Okay, this is the truth table of AND gate. So for realization of AND gate also, how many number of NAND gates are required? Two NAND gates are required. Okay, so let us take 0 0 first case. 0 0 means when both the inputs are 0 and 0 for the NAND gate, the output is 1. Okay, so one when you provide 1 1 for the again NAND gate, the output is 0. Okay, similarly 0 1. Okay, 0 1 means the output is 1. 1 1 1 1 1 is provided for this under NAND gate, the output is 0. Like similarly for 1 1. So if I provide 1 1, the output is 0. If I provide 0 0, the output is 1. Okay, means so in order to construct an AND gate by using NAND gates, how many NAND gates are required here? Two NAND gates are required. Okay, so similarly here two NAND gates are required, so you can select this NAND gate 1 and this NAND gate 2 on the trainer kit, and A and B, I1 and I1 or I2 or I2 or I3. Consider this as A input and consider this as B input. Simply connect to this I2 to one input of the NAND gate and I3 to another input of the NAND gate, and the output again this output is given to both the two other inputs, and this final output you want to show in the logic output. So for based on the inputs you are provided here, you will get the outputs here. So this is regarding realization of AND gate using NAND gate, OR gate. So in order to realize OR gate, how many NAND gates are required? Three NAND gates are required. So this is the truth table of the OR gate. So 0 0 0 0 1 1 1 0 1. Okay, so let us take first case 0. If you provide 0, if you provide 0, the output is 0. If you provide the okay, based on this all these operations, this is nothing but this combination is nothing but NOT gate. So if you provide 0, the output will be 1. If you provide 1, the output will be 0. So based on that, we will get the output. So this is how you implement the OR gate. The same connection here, you can use three NAND gates, 1 2 3, and three NAND gates are required for implementing the OR gate, 1 2 3. So depending on the final the output, This is the third one. This is given to the logic output states, and all these are the inputs. So here we will provide the inputs and given to this NAND gate. Okay, though this is how we can realize OR gate using three NAND gates. Okay, next XOR gate. So XOR gate, when you will say that the output of the XOR gate is high, when if odd number of ones, odd number of ones in the input are high, then the output is 1. Okay, so 0 1, two inputs are there, only one odd number, one is input is high, then the output is 1. Okay, so for realization of XOR gate, how many NAND gates are required? 4 NAND gates are required. 1 2 3 4. Okay, so by providing all the logic gates, so in order for realizing the XOR gates, how many NAND gates? 4 NAND gates. Okay, if the connection is made like this, the final output we will get 0 1 1 0 for all the 4 combinations. Means here by using only NAND gates, we are realizing XOR gate. We are getting the outputs of XOR gate if we combine like this. Okay, the same connection we will keep on the trainer. Okay, so here how many NAND gates are required? 4 NAND gates. NAND gate 1 2 3 4. All these 4 NAND gates we can utilize this. So here A and B, here A and B can provide the logic inputs. Here we will connect all these connections, and final output will connect it to the logic output indicator. So this is how we can realize XOR gate by using 4 NAND gates. Okay, similarly XNOR gate. Okay, so this is the truth table of the XNOR. How will be the output of the XNOR? Simply complement of the XOR gate. So we have already seen that this is a NOT gate, this is a NOT gate using NAND gate. Okay, this is a NOT gate using NAND gate. Okay, so by connecting the NAND gates in this fashion, we will obtain XNOR output. Okay, you will get XNOR output. Sorry, here 1 1 the output is 1. Here please do remember this. This is not 0. Here 1 1 for logic 1 1, the output is 1. Please, I have made a small mistake. Okay, so same connection here. 4 NAND gates are required, so you want to utilize this NAND gate 1, NAND gate 2, NAND gate 3, NAND gate 4. All the inputs A and B are providing from the logic gates, and the final the output you want to provide here. So the output you want to connect here. So like this, if you make connections like this, we will get we will realize the XNOR gate by using NAND gate. This is the procedure. So this is how we can implement all the basic gates using NAND gate. Similarly, this OR gate, NOT gate, XOR gate, XNOR gate, we can implement using NOR gate also. Okay, so that's why NAND gate and NOR gates are called as universal gates. Okay, thank you. Thank you.